Hello everyone. For this video, we're going to discuss the three different types of stability that we are more familiar with. Now, before we proceed any further, let's try to understand what the term stability means. Now, the term stability refers to the ability of the object to return to its original position when it's slightly tilted or slightly displaced. Right? It's the ability to return to its original position after being slightly displaced. Now, this sentence quite easy to remember, but it won't make any sense until we explore further. There are three types of stability that we are concerned with. One is stable equilibrium. The other is unstable equilibrium. And the last one is neutral equilibrium. Stable, unstable, and neutral. I'm going to run through the first two, which is quite distinct. The first two is quite distinct. Okay, the one which you may have difficulty grasping may be neutral equilibrium, but pay close attention to the key explanation, the keywords that I use later. Alright? Pay close attention to the keywords. Now, what I have here is an example of a stable equilibrium. So, on the left here, it's actually the original position of the object. Now, on the right, what I've shown you is that the object is tilted. Sorry, I will use the definitions words. The object is slightly displaced about a pivot. Right, so you anchor the object at that point there, and then you tilt it. Right, you anchor it there. It's not like you insert a pivot there, no. You just anchor at that point and you tilt it. And what you notice is that when you compare to the original position, right, in the original position, this is the base. I highlight in red, this is the base. Now, in the tilted position, a slightly displaced position, this is still the base. But notice the line of action of the weight, okay, passes through the base area. Alright, passes through the base area. Okay, sorry, before I forgot to add on, this dot here is actually your center of gravity, the point through which the weight appears to act through. Alright, the dot here is the center of gravity. Okay, now the line of action of the weight is actually passes through the base area. The one I draw in purple is now the perpendicular distance, and the weight is now the line of action of the force, right? And you have the pivot here. Okay, so I'm going to enlarge it. I have the pivot, the perpendicular distance, and the weight, the force. So, doesn't this cause the object to turn anti-clockwise? Right? So the object will turn anti-clockwise about the pivot and return back to its original position. But how about here? Again, this is a center of gravity. In short, I just call it CG. Okay, that's the center of gravity. The left side is the original position, and the right side is slightly displaced. Now on the left side, you can identify this as the base area. And on the right side, this is also the base area. And this time round, the object is slightly displaced about a pivot. And you note the line of action of the weight. This is the line of action of the weight. Now I'm going to enlarge this diagram further. And this is the pivot, the line of action of the weight, and this is a perpendicular distance. However, this is the base area, right? So the line of action of the weight actually falls outside the base area, and in this case, it caused the object to turn anti-clockwise, and the object will continue to fall and then topple over. Okay, you turn anti-clockwise and the object will continue to fall and then just topples over. Okay, so it doesn't return back to its original position. It really topples over, and that's why you call this unstable equilibrium. Right, it's only stable when it returns back to its original position, and it's unstable when it topples over. So always take note when analyzing situation like this, take note of the before and the after. Now, earlier on, I did mention that the neutral equilibrium, it may be a little bit confusing, but follow the reasoning. Follow the reasoning, okay? There are two ways to find neutral equilibrium, right? The most obvious example is a ball rolling on the floor. The most obvious example. And you have the CG here, and you have the CG here. Right, this is the original, and this is slightly displaced. Two things you can take note that helps you. One, the vertical height. The vertical height from the ground to the center of gravity is constant. It's the same. So when you slightly displace it, the vertical height didn't change. It remains the same. That's one. Okay. So once the vertical height remains the same, you can take it as it's a neutral equilibrium. The second point to take note is note the line of action of the weight. I'll change to another color. Note the line of action of the weight. Right, it passes through the pivot. Okay, the line of action of the weight passes through the pivot. And because it passed through the pivot, there is no turning effect. Hence, neutral equilibrium. So to summarize, there are three types of equilibrium. There's a stable equilibrium, unstable equilibrium, and the neutral equilibrium. Pay careful attention to your neutral equilibrium. Don't mix it up with stable equilibrium. Alright? Again, emphasize again, the point to know about neutral equilibrium is that the vertical height between the surface and center of gravity always remains the same, and there's no turning effect involved in neutral equilibrium. Right? And if you take a closer look at the stable equilibrium, there is a turning effect. Okay, there is a turning effect. So just pay careful attention to it.